let's take a quick look at the architecture of Uniswap v2. As mentioned in the previous video, Uniswap has three versions: v1, v2 and v3. v3 of course being the most latest. But because we are discussing the architecture of the overall Uniswap code, v2 is one of the most easiest and probably the smoothest to understand from an architecture perspective. So the Uniswap v2 core, or rather the Uniswap v2 section, has two set of repositories. One is called Uniswap v2 core and the other is called Uniswap v2 periphery. The core has a set of contracts which are used to create these liquidity pool pairs, and there is also a factory contract that is used to deploy these liquidity pool pairs. The periphery, as the name suggests, closely interacts with the contracts of core and has router and library contracts within this. Without further ado, let's go and explore the GitHub repo for the Uniswap v2 contracts. So if you look at Uniswap Labs, which is their github.com/Uniswap, which is their repository, you can see that there's v2 core and v2 periphery. In the upcoming lessons, we will be also exploring the v3 contracts, but let's quickly go through the v2 contracts as of now. So, as mentioned, the v2 core consists of pair contracts as well as contracts that are factory contracts. Now, let's take a close look at this Uniswap v2 pair.sol. This is a very simple contract where you have a mint, you have burn, and then you have swap events, right? These are basically the main functionalities, and then there is a sync event as well. Now, let's go and see what is the mint event. Sorry, the mint function. So, the mint function is basically returning when a new liquidity pool has been created or when a user is providing some liquidity to this new liquidity pool, right? So you can see that we are getting the balance of both the tokens, what is the amount, and then there is the mint fee and all of that. And once it is minted, this particular liquidity is minted, then we emit a message that this mint has happened. So what does it mean by minting liquidity? So every time a user provides some liquidity to the liquidity pool, for example, if there is an existing USDC/ETH liquidity pool and I have some USDC and ETH left over, I can submit my USDC and ETH to this liquidity pool and I will get something called liquidity pool tokens or LP tokens, which is what is being minted here. Of course, once I take the liquidity back from there, that I've got enough sort of incentives and I want to get back my liquidity, then we can burn as well, right? The LP tokens. You can also see the swap functionality. That is, if you want to swap ETH for USDC, USDC for ETH, any other ERC20 token for ETH, or any other ERC20 for the other ERC20, whichever has a liquidity pool created, you can swap those using this particular. So this is just your basic sort of Uniswap v2 pair.sol. And you can also see that there is a factory contract. This factory contract inherits the iUniswap v2 factory, which is the interface. And then you can see that here we are creating a pair. That is, every time a new liquidity pair itself is created. For example, if you're creating your own ERC20 token and you want to provide liquidity for that token against ETH or against USDC, against USDT, then you can create a new liquidity pair on Uniswap and provide the initial liquidity for that particular pair. Now, the factory contract is the one that is actually creating this new pair. You can see that there is the bytecode over here. You can see there is the initialize function that is being called in the v2 pair and all of the other respective functionality to be able to create a new liquidity pair. So the V2 contracts are very simple, and that's why we are going through this just to introduce the initial architecture. There's also the V2 periphery contract that which has the router and the migrator, that, and then there are libraries that interact with your Uniswap V2 pair and the factory contracts, right? So one of the assignments for you for this lesson could be to go through the V2 periphery and figure out the functionalities of this. Try to write a small article on this or make a small video so that you can share this with others who are also interested in learning. So this is pretty much it for basic architecture of Uniswap V2. There are some articles as well that I will be linking in the lesson that you can go through to understand in depth if you're interested to explore the architecture. There's also some mathematics behind Uniswap, which is not super complex but slightly complex. You can see actually in the libraries that there is some calculation that is happening in terms of like liquidity math, like how much percentage will be added when you're transacting, when you're swapping, how much percentage of that goes to the liquidity providers, how do you keep track of all that. So there is of course some mathematics. There is arbitrage that may happen, so how can the reserves get affected by that? So there is some mathematics associated with that as well, which you can go through and perhaps try to write something in a more simpler manner that others can understand.